All right, so yesterday or last time we met, we talked about quadratics in vertex form. So vertex form, remember the general form is y equals a. Then we have x minus h squared plus k. Okay, so that's the form we talked about or we focused in on last time we met. The reason vertex form is cool is because right from the form, right from the equation, we are able to find our vertex. Remember, the vertex is either the max or min of the graph. So it's either the top point or the low point. And when we're dealing with quadratics, the shape is always going to be in a parabola. So it's either a U opening up, or if we reflect it, it's going to go down. Okay, but it's going to be roughly in the shape of a U. So for this example right here, we're talking about height of a ball thrown in the air follows the path quadratic function. The graph is right here, so it's a parabolic path. They tell us that the vertex is 120, and the path of the ball includes the point. So really, they don't give us the point exactly, but we should be able to find it from the graph. They want to know what's an expression that defines this function. They want the equation in both vertex and standard form. Whenever we're going to write an equation for a quadratic, the first form we're going to go into is going to be the vertex form. Okay, we did the other day. We're going to follow the same process today. So you need to think, okay, what do I know? In the problem, they flat out tell us that our vertex is 120. So you need to remember, okay, whenever we're talking about vertex, that is going to be HK. So we have HK is going to equal 120. Okay, so that's explicitly given to us in the problem. After that, we need to think, okay, what else do we need to know? Well, remember, the key to these problems to write the equation is we have to find A. Okay, that's the first thing you have to do. You have to find A. So in order to do that, I need both a vertex, which we have, and then we need a point as well. So I'm going to go to my graph, and I'm going to try to find a point. And we're going to look for like the best point possible. And typically, that is going to be the y-intercept. Okay, so I got a point right there at 0, 4. So I'm going to have xy equals 0, 4. Now, the reason you want the y-intercept is because it makes our calculations a little easier when we plug in, which you'll see in a few seconds here. So now that I have my vertex and my xy point, we're going to go ahead and substitute in. Substituting in, we know that y is going to be 4. We do not know a. That's what we want to find. X is 0. H, so minus 1. We go ahead and square that. And then I have my plus 20 on the outside because that is k. So I plugged everything in except for a. And then now we got to work our way through, figure out what a is. So 0 minus 1 is negative 1. Negative 1 squared is going to give me a positive 1. So I'm left with 4 equals 1a plus 20. You go ahead and take 20 away from each side, and we're going to get a equals negative 16. Okay, so we found a. We're happy with that. Now what we need to do is just plug everything in except for x and y. Okay, so I need to plug my vertex and my a value in. So doing that, we're going to end up with y equals negative 16 x minus 1 squared plus 20. Okay, and that right there would be my vertex form. So that's vertex form. You can do a quick check. Like we could check a couple things here to make sure we're like on the right path. First off, the negative out front tells me that we're opening down, so that's good. Okay, the graph did open down. And then a vertex of 120 should be true. So I look at this, we have 120 is my vertex. We're good to go. Okay, so that is the vertex form. Next step, what we want is we want the standard form. So it's kind of like the new form for today, but not really. Standard form is when it's multiplied all out. So you have ax squared plus bx plus c. Okay, so you want it all multiplied out. We're not going to have parentheses or anything going on. We need to like get rid of all that. So what we're going to do is we're going to follow order of operations here. Okay, we're going to do PEMDAS. So PEMDAS tells us first we do the parenthesis, x minus 1, you can't do a thing with that. Okay, so since I can't do a thing with x minus 1, we move on to the exponent. My exponent is a 2. Okay, so when you have a 2 or square in the scenario like this, what that is telling me to do is to FOIL. So when I go ahead and rewrite this, this is really y equals negative 16 x minus 1 times x minus 1 plus 20. Okay, so that square tells me that the x minus 1 shows up twice. Now, to take care of that, like I said, you're going to go ahead and FOIL. So what FOIL tells us to do is you go first, out, in, and then last. So my first, x times x, is going to give me x squared. My out is going to be minus x. My in is minus x. And then my last would be plus 1. We still have the negative 16 out front, and then we got plus 20. I ran out of room, so I'm going to pick up over here up top. So before I worry about like multiplying the 16 in or doing anything with that 20, I want to make this look pretty. So combine my like terms. Negative x minus x is going to give me negative 2x. So I'm now left with y equals negative 16. In parentheses, it's going to be x squared minus 2x plus 1. And then I have the plus 20 still on the outside. Okay? So now, next step, multiplication still. You have this negative 16 out front. We need to take that negative 16, and like a sprinkler, it goes to every single term inside the parentheses. So that is now going to become y equals negative 16x squared plus 32x minus 16, and then we have the plus 20 on the end. The 20 did not get multiplied by the 16 because it's on the outside. Okay, only the stuff inside the parentheses gets multiplied by it. Last thing I do is combine like terms. This negative 16, positive 20, they're like terms. They don't have any letters attached to them at all. So we can combine them. And our final answer would be y equals negative 16 x squared plus 32x plus 4. And that would be our standard form. Boom, boom. Okay. So in the standard form, which we'll talk about a little more like next time, like it's real important to find A, B, and C. Since it's all multiplied out, we can find A, B, and C. We have A is negative 16, B is 32, C is 4, and we'll talk about next time we meet a little more what that means. So now, I got one more example for you. Make sure you do this, try it on your own. When we meet live, I'll work through it to make sure everyone's on the same page. Last example for 2-1. We want to convert a quadratic equation from a vertex form to standard form. They tell you that the function g is a translation of the parent function f. So we're going 1 unit left, 3 units up. They want to know what is the equation of g. So there's 2 ways you can do this, okay? First off, they flat out told us right here that we're going 1 left, 3 up. So if we go 1 left, 3 up, we know inside parentheses, we're going to have x plus 1 squared, and then up 3 would be plus 3. Okay, so we're gonna have that going on here. Okay, they flat out told us, like in the problem, we're going 1 left, 3 up. So remember, the inside is left, right, opposite what you think. Outside is up, down. You just do what it says. Okay. Now, from here, we do not know what A equals. Okay, so we need to use the graph to figure out what A equals. So G is this top graph right here. Okay, it's the one that was shifted. So in order to find A, the 2 things you need are the vertex, which we already have. Okay, you already have HK, and then we need a point. Just like last time, I'm going to pick a good point, and that good point, 9 times out of 10, is going to be the y-intercept. Okay, so I have an XY point of 0, 4. We go ahead, plug in everything we know, and solve for a. So doing that, y value 4, I don't know a, x is 0, plus 1 squared plus 3. 0 plus 1 is 1. 1 squared is 1, so I have 4 equals 1a plus 3. From there, take 3 away from each side, so I'm left with 1 equaling a. Okay? So now that I have a, we can do our vertex form. So our vertex form, our vertex form is going to be y equals 1, which honestly you don't need, okay? If you just have a 1, you can leave it blank. But 1, parenthesis, x plus 1 squared plus 3. Okay, so that's my vertex form right there. Standard form, just like we did on the last one, requires us to multiply it all out. Okay, so standard form. Your first step is going to be to FOIL. So when we FOIL that first out in last, we're going to be left with x squared plus 2x plus 1. And then I have a plus 3 on the end. Okay, last step, combine your like terms. So you're going to have with x squared plus 2x plus 4. With this, I guess since we started off with a function g, I should probably write in function notation. So instead of y, I'm going to go g of x equals. Just realize when you write it like this, g of x, it's the same thing like as an output. It's the same thing as a y. Okay, so I could have written this one up here as well. G of x equals x plus 1 squared plus 3. Either way works. Technically, though, I guess we should use the g of x. Okay. So you got one more example you need to try on your own. So on the next page, the highlighted one, please make sure you try that one on your own. Hopefully you picked up a printed packet because it's a lot easier if you have it. And then, yeah, make sure those two are done. Make sure the homework assignment's done from the other day. And be ready to go when we meet live.